Okay, good morning students. We came today class functions first part. Here before starting the functions, as same previous lesson, we should go for the review what we are completed in the first year. We should know the definition of the function. Without knowing the definition of the function, again we cannot further move in this one. Now what is a function? What is a function means if we consider let A comma B are two non-empty sets and a relation defined from set A into set B is said to be a function. There is two condition. If every element of A is associated with only one or unique, one means only one means unique element of B is said to be a function. That is, every element of A must should be associated with unique element. Two conditions observe there. Every element and unique element, that is unique element. Now here it is f map and it is denoted by f maps. A to B reads as the function f maps set A into set B. Now set A here f maps said to be now set A is called as domain and set B is called as codomain. Further, the set of all the elements of the codomain which are associated with the elements of the B. For example, if you are associated here, observe their example, A, B, C, D is their codomain. But here what is there? The elements associated with the elements of A are A, C, D. That means the set of elements of codomain which are associated with the elements of A, that is domain, is called as range of the function and it is denoted by f of capital A. Observe the example here, A to B we are mapped here. Now this is a observe there, every element of A is associated with unique element. Therefore here what is the domain? Domain is 1, 2, 3. Codomain is A, B, C, D, but range is A, C, D. This is the regarding some functions. Now further, what we can define, observe there, here function means let A comma A belongs to A and B belongs to B such that f of A is equal to B. That implies the ordered pair AB belongs to F. That means we can write this as F is equal to A comma AB such that A belongs to A and B belongs to B. Here now the element B belongs to B is called as image of the element A belongs to A. Similarly, the element A is called as pre-image of the element B under F. Now we are moving into the segment types of function. This is the particular for second year topic. Here now one function. Let A be a function F defined on set defined from a non-empty set A into set B. That is, f maps A to B is said to be one function if every element of A is associated with a unique and distinct element of B. That is, for all x1 comma x2 belongs to A such that x1 is equal to implies x1, f of x1 is equal to f of x2. Otherwise, you can take in the reverse order. That is, otherwise x1 does not equal to x2, that implies f of x1 does not equal to f of x2. It is also called as injective function, simple injection. Otherwise, it is said to be many one function. Observe the following examples now here. If a function is defined on f of A is equal to 1, 2, 3 by f of f is equal to 1, 1, 1, 2, 2, 3 and 3, 3. If you map this one diagram, Venn diagram, what you are going to get? 1, 1, 1, 2, 2, 3, 3, 3. Now here no problem, but here 1 is associated with the two elements. Definition only fails, no? Actually it is not a function only first of all. That's why here the element 1 has two images, hence it is not a function. If it is not a function, there is a secondary case, it is a 1, 1 or not. If you are observed this one, this is 1, 1 function. This is many one function. This is the case of 1, 1 function. Onto function. A function f maps A to B is said to be onto function if every element of B belongs to B, there exists at least one pre-image in A belongs to A. That is simply range of the function is equal to codomain f of A is equal to B. For all B belongs to B, there exists an element A such that f of A is equal to B is called as onto function. For example, if you are taken this one example, observed there, it is a maybe function, but observe there here there is no pre-image to the Z is not associated with any element. There is no pre-image in A. That's why here it is not onto function. When you come to here, it is onto function. Observe there. Why? Because here what you got now here? Here we got 4 and 5. What is a codomain? 4, 5. What is the range? 4, 5. Ultimately, it is a onto function. Onto function also called as surjective function. Onto function also called as surjective function, or simply it is surjective surjection. And if it is not the surjective function or onto function, it is said to be into function. Now we move to the bijective function. If the function is f maps a to b is a 1 1 and also onto, that is injective as well as surjective, then it is said to be bijective function. Observe there, this is only 1 1 function but not onto function. Why? Because there is no pre-image for the b. If you take this is onto function but not 1 1 function. Why? Because two elements has same image. Now when we are moving to the third example, it is a 1 1 function as well as onto function. Observe that every element of A is associated with unique and distinct element, as well as codomain is equal to range, otherwise range is equal to codomain. Therefore it is 1 1 and onto function, that is bijective function. Here further, bijective function also in called as in future, it is the invertible function. Check whether the function f maps R to R mapped defined by f of x is equal to x plus 4 is bijective function or not. For example, 2x plus 4, what is that one? If you draw a line, this is y is equal to 2x plus 4 means what is the coordinate? This one is the 4. This is the y is equal to 2x plus 4. The slope is 2, positive direction. That's why what you are going to get observed there. This is a straight line. A straight line means what is the domain of the straight line, and range of the straight line is the R to R. Therefore it is clearly onto function only, that is bijective function. 1 1 and onto, that is bijective function. But we have to verify mathematically, that is x1 belongs to x2. If you have taken 2x1 is equal to 2x2, adding on, multiplying with 2 on both sides, adding 4 on both sides, this one f1, that means x1 is equal to x2, implies by implies f of x1 is equal to f of x2, that is f of x is 1 1. Otherwise in the reverse order also you can come, that is f of x1 is equal to x2 if you have taken x1 is equal to x2. Therefore this is 1 1 function. Now let y belongs to R, that is a codomain if you have taken, then what you got? F of x is equal to y. This for here x defines and it is a real number, therefore x belongs to R, therefore is onto. Clearly it is bijective function. Okay, here I am attached a PDF file also. You can download PDF and you can check here. Thank you.